let's talk about the growth rate functions. Growth rate is related to the problem size n. We care about the n to be very large. So let me elaborate by using this Excel file. Here, I plotted the graph of the value against the input size. So you can see that if we have the input size increase, correspondingly, the value of the function will change. So first, let's see the case of the n squared, n cubed, and n to the power 4. How would it be changing? We compare with the case 1. That is, the value is keeping constant. So you can imagine that actually when the n grows, then higher the power of n, then the higher the rate of increasing. So you can see that n squared is actually growing much faster than n. So it is a simple idea. So how about the logarithmic function? So let's just take the logarithmic function. Then you can see that the growth rate, you can see this blue line is n, and you can see the growth rate of log n and log n is less than that of n, and log n is less than log n. Therefore, if we can keep the growth rate low, then the processing operation will keep in low level, even the input size is growing. So in particular, if we have a large number of it, for example, okay, let me change the data source. Then you can see that if we make use of logarithmic representation, when the number is going very large, then the logarithmic function will keep the value low. But if the n involved, then the size will grow accordingly. So if we look at the power functions, okay, so you can see that the growth is even more dramatic. So not to mention, if we use the 2 to the power n function or 2 to the power 2n function, okay, then it would be sharply increased. Okay, so you can imagine that, okay, in terms of Excel, okay, these are the over the limit that it can represent. So I hope you will have better idea of the growth rate of different functions when related to the calculation or evaluation of the complexity